Okay, I'm back, and now we want to talk about resistors in parallel. And notice we're going to use the same numbers that we used when resistors were in series. And so we're still going to use the battery voltage is going to be 15, and resistor 1 is still going to be 12, and resistor number 2 is still going to be 18. So if we go back to here, now we need to put this thing in parallel. And so in the lab, I ask you to go to the internet, and I need for you to find a picture of two resistors in parallel with the battery, and then to reproduce that on your screen. Go. Do it. Okay, have you done it? I bet you haven't. You're just waiting for me to go on here. But really, I do want you to do this, because if you do it, you're going to learn a lot more than if you just watch me do it. But I know you want me to do everything for you. So let's put our ammeters away. Simplify this. And then let's go ahead and I'm going to cut this one out. So if a series circuit was a conga line, then a parallel circuit is going to be more like a ladder. Now you'll notice that I'm using a lot of wires in order to do this, and it's kind of important that you use a lot of wires when you do this. So there's a reason for this. So I'm using a lot of wires in order to make this picture here. Are you having a good day? I hope so. I wish I had some music. So there's a painter here in the United States, Bob something or another, and he does these paintings, and he has this very quiet music going on in the background. Okay, so now back to our regularly scheduled lab here. Bob Ross. So here is the parallel circuit, and some things that I'd like for you to note is what happens if we open the circuit on one of these. So let's open it here. So if I open the circuit here, do you see that there's still some electrical activity going on in there? So that's characteristic of a parallel circuit, is that if you open the circuit, not all of the circuit goes dead. Now this one did, so there's no electricity going through this one, but electricity is still going through this one. Now compare that to the series circuit. So when everything was one big conga line and you opened the circuit, what happened? Then everything shut down. But you notice that doesn't happen when things are in parallel. So that's kind of important. Okay, now we need to measure or calculate the total resistance. So let's go back to the lab here. Okay, now it says to take a snip of that picture and then put it here. So this is just your proof to me that you're actually doing the lab. So now let's take a look at this thing here. So we had a formula when things were in series. So let's put this up here. So R total, and then when it was in series. And that was R1 plus R2. So that was the conga line. Now we want to do resistors in parallel. And so notice the formula looks completely different. So it's 1 over the total resistance when it's in parallel. Now you don't have to write all of that out if you don't want to. And then that's going to be equal to 1 over R1 plus 1 over R2. Okay, now let's do, this is kind of tricky, okay? So let's do this, a worked out example of how to do this calculation, because students really have problems with this. So let's say, now I'm changing the numbers here. Let's say that R1 was a 1, and then R2 was a 2. So we're going to use very simple numbers here. Let's figure out what would be the total resistance if R1 was a 1 and R2 was a 2. Now if it was in series, our answer would be 3 ohms. So 1 plus 2 makes 3. But this is different. So this is going to be 1 over R total is going to be equal to 1 over 1 plus 1 over 2. Okay, now 1 divided by 1 is 1, and then 1 divided by 2 is 0.5. So that means that when we add these together, we get 1.5. And every time that I do a test, there's somebody that says, yep, that's the answer. The total resistance is 1.5 ohms. No, because this is 1 over R equals 1.5. So if I was to take this over to the other side, I would have 1 would be equal to 1.5 R total. Okay, but it's still not right. I need to have the R total by itself. So I need to take this over to the other side, and so that means that R total was 1 over 1.5. Now I don't have my calculator with me. You can do that. So 1 divided by 1.5, and it's going to be a decimal that's less than 1. And then don't forget to put the unit on there. So what you're going to do is you're going to use your two resistances. So you had a 12 and an 18. And so you're going to take those two resistances, put it into this formula, and then solve it, and then put that number right here. Okay, very important that you be able to do that. All right, so the next part down here is that we need to measure the currents and the voltages. I'm having difficulty seeing you, so I am going to erase this stuff here. Yeah, there you are. All right, so let's get rid of some of this. All right, so now we're going to go back to the simulation here, and we need to measure the voltage. So we get out our voltmeter, and I'm going to let you do it. So you're going to need to take the probe, put it here and here, and then that's going to be the voltage of the battery. So I just want you to verify that. Okay, then I also want you to take the probe and put it over here and put it over here and measure the voltage across this resistor, and then take the probe, put it down here, and put the probe down here, and then measure the voltage across across this resistor. And something kind of interesting happens. Because if we go back to the lab here, you're going to notice that the voltage is the same everywhere. The voltage on the battery is going to be the same as the voltage on resistor 1 is going to be the same as the voltage on resistor number 2. And so you're going to put that up here. So we've got the measured voltage of resistor 1 and the voltage of resistor number 2. So put those two numbers right here and here. Okay, then we need to measure the currents. Okay, so we're going to go back to the simulation and we're going to get rid of this. Now, this is where it gets kind of tricky because I need to get out 3 ammeters and I need to insert them here. So I'm going to measure the current going through this resistor. So we'll do that by opening it up and then sticking this one in there. And then we're going to do the same thing here. So we're going to open this one up. Now I'm going to let you do it. And so we're going to take this one and we're going to put it in there. And then I need to do the same thing here. So I'm going to open this one up. And then I'm going to take this one and put it in there. So I'm going to let you do it. So you're going to, that's the reason why we had to have so many different wires on this one, is so we could get all those ammeters in there. So that's going to allow you to measure the different currents. And so you're going to put the measured current here, the measured current here, and then the measured current here. And then notice if we go down to here, it says you can even calculate the total current. So here's the total current when something is in parallel and you add the two currents together. So I want you just to verify that. So this number here, whatever it is, plus this number here ought to equal this number down here. So just verify that that's true. Okay, now we need to calculate the currents and the voltages. We're going to calculate the currents and the voltages. So if you need help with this, if you go back to the notes, okay, you can, here's going to be the procedure. So this is the procedure that we're going to use to figure out the currents and the voltages in a parallel circuit. And then here is a worked out example. So if you'll go to your notes, you can look at all of that. And so this is exactly what we're going to be doing in lab. So let's go back to here. Now it turns out that parallel circuits are much easier to do than the series circuit, because in a parallel circuit it's the voltage is the same. So in the series circuit it was the current was the same, and in the parallel circuit it's going to be the voltage is the same. So what we're going to say is that the voltage on the battery is voltage 1 is voltage 2. We didn't even have to do any calculations. So the voltage 1 is the same as voltage 2 is the same as the voltage on the battery, because everywhere in a parallel circuit the voltage is the same. So now we got the voltages. What do we need to get? The currents. So what are we going to use? Ohm's law. So we're going to write down that V is equal to IR, but if it's resistor 1, let's put voltage 1, current 1, resistor 1. You know what resistor 1 is. You know what voltage 1 is, because that's the voltage on the battery. So now you can solve it for I. Okay, now what about current 2? How are you going to do current 2? Okay, we're going to write down Ohm's law. And instead of a 1, we put a 2. So we know resistor 2. We know voltage 2 because it's the voltage on the battery. And then we solve it for current number 2. And then go ahead and put that information in right here. And then you can add the two currents together, and then that's the current that goes down here. But also, if you look on your, if we go back to the simulation, so this would be the current on resistor 1. This would be the current on resistor 2. And then what do you think this one would be? So this current is the total current. So if you take this number and this number, it should be that number up there. Okay. Are we having fun? That's the important thing, is we're having fun here. This is a lot of information. That's why we're spending 2 days doing this. And now let's take a look at this. So here's our summary. So here is how to calculate the resistance when two things are in series. So it's R1 plus R2. Here's how to calculate the total resistance when they're in parallel. So that's this one. Okay, then we said that everywhere in a series circuit, the current is the same, and then everywhere in the parallel circuit, the voltage is the same. And then in order to find the voltage, you just add the two voltages together. And in order to find the current when it's in parallel, you just add the two currents together. So I encourage you, I plead with you, is that you would go back to here, go back to your lecture notes and review all of this stuff and practice doing this. So if you go to the internet and you type in how to solve a series circuit, and then you could either go to images and you'll see lots of stuff like this where they work it out, or you can go to videos, and there's lots of videos that shows you how to do it. Same thing for the parallel circuit. So find videos that show you how to do it. Maybe there's an easier way of doing it than what I did, but I've found that this is pretty, it's easy for me with a master's degree. All right. Okay, so now let's go back to the lab, and I need for you to do the post-lab questions. So now that you've done the lab, you can go back up, find the purpose of the lab, and then cut and paste. You can find pictures of what a resistor, power supply, ammeter, and voltmeter look like, and you can paste those pictures right here. Okay, you should know what does an ammeter measure. Okay, then for this one, you could, if you want, you could take this picture, copy it, put it into Microsoft Paint, and then circle in Microsoft Paint which one of these is the correct one, and then paste it back in here. Or you could just say picture 1, or you could say picture 2. So it's up to you. however you want to do it. But you need to indicate which of these two pictures is correct if you want to use an ammeter correctly. And then same thing down here is which of these two pictures is correct if you want to measure voltages correctly. Okay, then write down what is Ohm's law. Okay, here is a math problem using Ohm's law. Okay, then here is what is the same everywhere in a series circuit, what's the same everywhere in a parallel circuit. Okay, here is a mistake. So that should be 2 ohm. So I forgot to change the capital W into a ohm symbol. So a 2 ohm resistor and a 3 ohm resistor are in series. What is their total resistance? And then here is your last question. I'm slipping out of my chair. Sorry about that. So question number 12. The two resistors from question number 11 are in parallel with a 6-volt battery. What is the current in each of the two resistors? So that's exactly what you just did in lab. So we're done. So now we've done 2 labs based on this one lab. Okay, so I hope you enjoyed it. I certainly did. And so in our next lab, I think we're going to be doing some things on harmonic motion. So I will see you then.